So Coulomb's law is going to be a really handy concept, not just in physics, but also in areas such as chemistry, because when charged objects are placed near each other, they experience an electrostatic force that can either be attractive or repulsive. And as we've said in the previous video, objects that have the same charge repel each other, while objects with opposite charges attract. And Coulomb's law gives us a way to really quantify this force of repulsion or attraction by giving us a formula that we can follow. It's dependent on three things: the charge of the first object, or Q1, the charge of the second object, which we'll call Q2, and the distance between those two objects, which is d. In general, Coulomb's law looks like this. The electrostatic force between two objects is equal to Q1 times Q2 over d squared. But that's not all of it. There's also an experimentally determined constant called k in the numerator, which takes on the value of 9 times 10 to the 9th power. So since k is a constant, it's going to be the same every single time you use Coulomb's law. Conceptually, this whole equation makes sense. The greater the magnitudes of the charges, the stronger the force should be, making the numerator larger. And the smaller the distance between the two objects, the stronger the force should also become, which makes sense why d is in the denominator. Now, when you use Coulomb's law, you don't necessarily have to put in the signs of the charges of the objects. For example, let's say we have an object with a charge of positive 3, and another object with a charge of positive or negative 2, and the distance between them is 1 meter. Since they're oppositely charged, we know that the force between them is going to be attractive. So when we plug in positive 3 for Q1 and negative 2 for Q2 and 1 meter for distance squared, and also don't forget about k, which is our constant of 9 times 10 to the 9th. Let's see what we get. So 9 times 10 to the 9th times 3 times 2 over 1 squared, which is just 1, and that gives us 5.4 times 10 to the 10. And don't forget that this is going to be negative because the positive and the negative multiply to make a negative. So 5.4 times 10 to the 10th. And that's going to be in newtons because this is a force that we're talking about. So since they're oppositely charged, we know that the force between them is going to be attractive. And keep note that if you do plug in all the signs, a negative answer will mean that it's attractive, and a positive answer means that it's going to be repulsive because any two like charges will cancel out to give a positive number.